video is looking at the 2017 Ordinary Level Section A. In the first question, A1, it's perspective drawing, and we're asked to complete the remainder of it. They've brought an awful lot of the lines down from the plan, through the picture plane, and down into the perspective drawing for us. So a few things that we need to continue with. We're going to take this line here and project back to the vanishing point. So this line here back to the vanishing point. And we can do that for each of the points on the steps. Projecting those back along this way. Now, vertical lines, or I shouldn't say vertical lines that are following this angle here, I'm going to need to project those up. So we're extending this line here up for the step. That gives me that point. I can then take this point back to vanishing point 1. Until that crosses the line coming the other way. So where they cross then is going to be here, and that's going to continue up to touch the top, and then back to the vanishing point again, and we can darken in that line. So finally just need to darken in quite a few lines. And that completes question A1. Looking next at question A2, this is based on a conics and it's a parabola, two semi-parabolas. So this is not the vertex. The vertex is here, and this is the other vertex. So our curves are going to go up either side. They've given us a couple of points already, so we can draw these out along. So this top side here is 51 millimeters, dividing into 6 equal parts is what I think they're going for here. So take a line off it, any angle, mark off 6 sections that are all the same. So 6 sections, join the last one back to point B, and then we'll take all the others parallel to that as well. So we don't need to do the first two because they're already drawn for us. So joining these, then down, and that gives us the other 2 points. We already had point 0 here, 1, 2, 3, 4, and 5. We already had those two. Going to do the same thing coming through the center. So what you can do for this side, and you could have done that up there as well, measure the distance here with your compass, and let's mark that off 6 times. You have to be really accurate with these. That gives us our 6 points here. So taking these lines, this way. So again, labeling these points 0, 1, 2, 3, 4, 5. So joining point 3 here up to the vertex, and then where that crosses the other point 3 is a point on the curve. Joining line 2 to the vertex where that crosses this line 2 is a point on the curve. Joining line 1 to the vertex, that crosses another point on the curve. So joining all of these up back down to B gives me my parabola, and this is, so that's the first part of it. The second part of it is the second semi-parabola is rectangle this, so B, C, D, and V1, and it's a mirror image of this one, so we can just mirror this across the opposite side. So instead you can redraw it if you wish, but a much quicker way, and when they tell you that it's a mirror, they want you to do this. So you're taking this distance, swinging it around to the other side, putting the point of your compass here on point 2 on the axis, measuring up to the point on the curve, marking that same distance out the other side. Same for point 3, and so on. And finally, last point, point 5, onto the other side. And I didn't have the line there for that. So again, this is a point. Each of these are points, so best curve that you can, joining each of these points up. And that completes question A2. Question A3 is a rotations question. So we're given this bridge here in its closed position. We need to rotate this into its open position until A is in line with A1 up here. So each point is going to rotate 60 degrees. So what we're going to do is we're going to join, I'm going to label a few other points. This is B, C, D, E, and F is in here. Sorry, this is F and G. G is just, they're very close there, and they've already drawn that on for us to make it a little bit easier. So for each point, I'm going to join point P to the point. So joining point P to B, taking my protractor, I'm going to measure an angle of 60 degrees around that line. So I'm putting the center of my protractor on the point P where it rotates, and the 0 on the line joining to B, marking 60 degrees up here. And now I draw a line from P up through that point. So point B is somewhere along that line. Point my compass now onto point P, out to B, and I rotate that around up. This is now point B up here. Same process for all of this, joining point P to point C. Protractor on P, rotate the 0, lining up with C, measuring 60 degrees up along that way. And same again, so again measuring the distance from P to C and swinging that up this way. So we have A, B, C in line with each other up here. Going to do the same thing for point D. P joins to D, 60 degree angle. This one. Angle, measure the distance from P to D and rotate that up onto our line. This is point D down here. E is the same, so P joins to E. So all of these points are done the same way. The process is the exact same. P joins to the point. You put the percent of your protractor on P, the 0 lining up with the point, mark 60 degrees. Redraw this line at 60 degrees, and then swing the point onto the new line that you just drew. This is E, and F is, they've already given us F, sorry, they've given us G, which is this one. So for G, to find F, we're going to do something slightly different. E to F, or E to G is there, to D is this one, and we'll come back and we'll find G shortly. So this goes up to there. You can darken in from this up, so not touching P. To find this line in the middle, we need to locate point G. To locate point G, the best way that we could do this, instead of trying to measure the angle because it's, or sorry, point F, is because it's so close, it would be easier if we just swing it onto the line. So we know that it's going to be on the line joining E to G. So if I put the point of my compass here on P and swing from F onto that point, that gives me the point on the curve where that is. And then I can just join them up. And that is question A3 completed. Final question A4 is solids in contact. So a desk tidy in the form of geometrical objects which are in mutual contact is shown in the 3D graphic below. The solids rest on a rectangular base. The drawing on the right shows the elevation and partially completed plan of the desk tidy. Consists of a cylinder, a sphere and a cone, and the sphere and cone have been truncated as shown. Draw the plan of the truncated cone B and draw the plan of cylinder C. So starting with the truncated cone, we know that it touches off of this here, and what we also know from looking at it is that it is directly, the center of it is directly in line with the horizontal from the center of the circle. The reason I know that is we can see the point of contact between them. If, like for example on this one, this cylinder is down here somewhere, it's in front of it because there's hidden detail. There's no hidden detail on this part, which means they have to be in line with each other. So all we're going to do is we're going to project the center across this way. So our center is somewhere along that line. Center is going to be directly below where it is in the elevation. So this here is going to be the center. The top radius for what we can see in plan is the outer one. So when looking down, it's this distance from here to here. That's the width of it. So that's going to be a circle. But we also have, we can see into it. So it's hollow. So we can see the bottom of this as well. So we can see where that's truncated. So we're just going to have a little bit there also. So to do this, and now this bottom one will probably be difficult. So draw it as best you can. So what I have down here is this circle, this radius. So this is diameter. This is what we can see at the bottom, and that's the first one. And then the second circle is going to be for the top of the cone, the wide part of the cone. So we're drawing this circle down here next. And then underneath this, so they left this line here partially red because we can't see it. So what we can do is we're going to darken that in until it touches the circle. Now you can use your compass for this. And just hidden detail lines then after that, because when we're looking down on top of it, I can't see this part of it. It's hidden behind that. So that's the first one, that's B. So this circle with the smaller circle. So smaller circle is this, big circle is this up here. Brought down the center point, brought down the two widths and drew my two circles. For this one down here, for our cylinder, we can project our center down along here somewhere. So I know that my center is going to be down, it's on along this line somewhere. The cylinder touches off it, as we can see here. Okay, so what we need to figure out is how far away is the center of this, the center of the cylinder going to have to be from the center of this one, so that they're touching each other and not cutting through each other. So to do that, we're going to do one thing. We're going to add the radius of the cylinder onto the radius of the sphere. So I'm just going to do this down here. So measuring taking this distance from the elevation, so measuring the radius. So this here is the radius. So from the center point out to the side is the radius. I'm going to add that onto the side of the sphere. So that's this distance here. And then I'm going to swing that distance around. So anywhere along that line I could draw that cylinder and it would be in contact with the sphere. But I need it in a specific position. I need it in this position down here because it's directly below where it is in the elevation. So now I can draw this in plan, and that is the cylinder in plan.